My name is Vikram Manikonda. I'm the president and CEO of a small business called Intelligent Automation. We are a technology innovation company located in Rockville, Maryland. I'm joined here by my colleague Dave Mayhew, who's a principal at IAI and the lead engineer of this technology. Before we present Argus, I just want to set the stage of why there was a need for this technology, or why there was a perceived need, and what made IAI go after this. So as many of you know, there are fewer and fewer troops left in Afghanistan and Iraq, and the troops are being pulled back. There is fewer resources available to protect our bases, our command outposts, and our assets that are there. Good examples of these are the recent attacks on Camp Bastion in the Helmand province in Afghanistan, the al-Baghdadi attacks that happened in Iraq. All these cases because we did not have sufficient perimeter surveillance, and there were gaps in the surveillance of these bases that the intruders were able to cut through the fences and get in and attack our troops and our soldiers in these forward operating bases. This came to us as a requirement that as there's fewer and fewer soldiers or warfighters available to protect these forward operating bases or command outposts, there is a need for a technology that gives you an early warning system for intrusion detection. And to cover the gaps that are provided by visual systems or radar systems, these systems need to be rapidly deployable, they need to be low cost, and maybe even left behind. And that's what led us to start inventing and building this technology that we called Argus. It's essentially an RF-based, unattended ground sensor system that can be rapidly deployed in less than 20 minutes to protect a command outpost, an asset, troops, or to provide them an early warning system. I'm going to let Dave Mayhew talk about the system over here and go through the technical detail.
I'm the lead engineer with the Argus technology. So this is a one-slide overview of Argus and its capabilities. Vikram already touched on a few of the points here. I'll just reiterate, it is an unattended ground sensor, and it is designed for outdoor use, of course, to provide that early warning capability that Vikram mentioned. It's capable of very long-term unattended operation from 1 month to 4 years and beyond, depending on your battery. And of course, it's great for many applications: protection of combat outposts, patrol bases, high-valued assets, forces on the move, etc. So in terms of what Argus is, what it does, how it's different than other UGs that are out there, this slide attempts to capture the principle of operation of Argus. So Argus is an RF-based tripwire system. So it's a mesh of sensors. This is our typical sensor right here. It's RF-based, meaning the sensor itself is the antenna. There's no optical sensor, there's no seismic, although we have that capability. The primary sensor of Argus is the antenna itself. Each node serves almost like a fence post in a wireless fence. So you can set them out in a long chain or a perimeter and enable the links between all of them. And it's also worth noting that each sensor can be connected to multiple trip lines. So it's not a one-to-one type of relationship. You can have a whole mesh of them and have each sensor connect into many different neighboring sensors and have lines of sensitivity in all those areas. The antennas are omnidirectional, so it works in that way. In this depiction, hopefully makes it pretty clear how it works. You have two sensors on opposite sides of the screen. As they're communicating with one another, as the intruder walks through, the system detects that and sends an alert back to a PC or remotely. So we wanted to really make clear what unique capabilities Argus has. It's clearly a unique sensor. It works different than most other sensors out there. But what unique capabilities does that enable? So as Vikram mentioned, it's very rapid deployment. Because you do not have to align the sensors, you basically just take them out, stake them into the ground, and turn them on, and that's deployment. So you just set them up however you'd like. You do not need to dig them in or bury them like with seismic sensors. You don't have to align them, as I said. There's no calibration. They completely self-calibrate. They adjust dynamically to the changing environment. Each sensor includes GPS, so they localize themselves onto a map for display. It performs very well in many environments, and this is one of the really, really unique and important capabilities that Argus has, different than most other sensors. It's, of course, indifferent to soil conditions. It's not in place like a seismic sensor, so it can go over sandy, rocky, muddy soil. It doesn't matter. It operates in any weather. As I mentioned, it adjusts if it starts raining, if fog rolls in, if it's windy and the foliage starts moving, it compensates for all that dynamically. I mean, it's very, very low false alarms, even in very dense foliage. I have a slide in a few slides ahead that shows, we're talking about jungle-like foliage here, that these can be completely obscured from one another behind foliage. It is RF based. It works not only through foliage, but it works through optical obscurance like sheets, and it'll go through walls. It'll go through plastic traffic cones, things like that. Basically, anything that's not metal, it will go through. There's also a beyond line of sight operation capability. Argus includes a low power wireless sensor network, and so it has provisions. There's an add-on port here, or it's an I/O port here that additional sensors can be connected into it. So you can deploy Argus up and over a hill or down into a gully that you can't see and that's kilometers away, and you can provide reach back to the base for other sensors. So we have a few slides here that kind of show some of the details now of how Argus works, what the capabilities are. So in terms of delivery of alerts, here on the left side we have an Argus sensor network connected to a PC where the alerts would typically be delivered to some sort of PC capability. Down at the bottom is a very small form factor pan tilt zoom PTZ camera that we've got integrated as part of our system. So in the case that an intruder walks through Argus, walks through the sensor network, the alert is delivered back to the PC, and optionally the PC cues the PTZ camera to point in the direction of the alert and grab an image. So it could just stop there. The alert and the imagery could be delivered to the PC. Optionally, that alert and the imagery can go up to a server on the cloud, somewhere on the internet or on a local network. It can go up to a server, and from there, it gets stored and it can be delivered to any of numerous different types of clients anywhere in the world, pretty much. Android platform, other situational awareness systems like RaptorX, Spyglass, or of course other instances of our software running on other PCs. In terms of fence configuration, as I mentioned earlier, each sensor it's not a one-to-one type of configuration that it imposes. So this is this is actually a snapshot of a deployment we did at a demonstration. Each of those black dots represents an Argus node emplaced at Fort Sill on their quad. And the blue dotted lines and yellow lines indicate all of the links that Argus sees, that it could create as lines of sensitivity for intrusion detection. And then as the user, you can simply select which ones you actually care about and enable it, and away you go. As I mentioned, GPS is enabled. Each sensor includes GPS so that they populate themselves on the map automatically. This is a snapshot of our graphical user interface. There's a lot of information overlaid on here, but it actually is quite simple to use. It is map-centric, so there's a main map in the middle where all of the nodes are displayed, and the links of sensitivity are displayed. And then optionally, you can show these other panels that we've got displayed. On the left side is the sensor status, battery life, and so forth. At the bottom is a log of all the alerts. As alerts are detected, they are logged to a database on the PC, so you can review that in an after-action report. And on the right side, those red boxes indicate the active alerts that the system has detected and that the operator has not yet acknowledged. So if the operator is away from the computer and they come back, the record of some event having occurred is there. As I mentioned earlier, also the Argus includes optional PTZ and camera integration. So here we've shown, again, this is our graphical user interface on the laptop that we've got right there, actually. And here we had a camera active where when an alert occurred, the camera slewed over and took a picture. It's difficult to see on this from so far away, but there is an intruder that if you were looking at it live, you could see the intruder on the left side. And then the PTZ camera also has thermal capabilities. So in the bottom there's a troop of people walking through, and we captured that at nighttime. We captured that on the thermal camera. In terms of interoperability, Argus plays very nice with other systems. We've integrated with other systems in numerous occasions. Argus outputs a standard cursor on target format. We've integrated with the BETC standard ground station SGS UGS ICD. We've performed lots of experiments and done lots of test deployments where we've pumped our data out to RaptorX, the BETC SGS, as I mentioned, to Android Tactical Assault Kit, ATAC, and also now we're pumping out data over the Integrated Sensor Architecture, ISA system, that the Army is investing heavily in. This slide shows the technical specifications, which we've touched on throughout. Basically, it is designed for rugged outdoor use. It is an outdoor system. It's designed for long-term unattended use. 4 weeks to 4 years runtime, as I mentioned. I think I hit on all those. A key spec here is the range between sensors, which I didn't mention earlier. In between each sensor, it can be up to 200 feet. You can have them as close as 2 feet or as far apart as 200 feet. And that's the sensitivity zone for the fence links. And then the range actually to backhaul that data to the laptop can be much further, in excess of 1 kilometer with good line of sight. Argus, as I mentioned, also has a low-power wireless mesh network capability, so if you need to go more than 1 kilometer, you can simply chain additional nodes back and you'll get that relay of alerts. On the right side, we've shown a couple different instances, embodiments of our sensor. Argus, the standard version, which I've got right here, is shown kind of top left image, but then we've also incorporated this into a pole for more long-term permanent installations where they want it to be a little more covert. So here we've got a sample of the pole that I mentioned, where the Argus PCB and the batteries and all are incorporated right inside into a fiberglass pole, so it's very rugged, and that can be staked into the ground or mounted however you'd like for extremely long term, up to 10-year type of durability there. I mentioned earlier that Argus works very well in foliage, and along those lines for these long-term unattended pole type of deployments, there's a lot of interest in camouflaging the sensor. So here we've shown a couple examples of how we've camouflaged the Argus pole. On the left, we've shown just simply a camo paint job, which works well, but not as well as on the right side. We've got our ghillie suit version, where we simply made a ghillie suit sleeve that goes over the Argus node. And actually, we've got it back there next to our kit if anyone wants to see it up close. But when that sleeve is over the Argus node and you put it out there in the woods, even though I know where I put it, I have a hard time going back and finding it. And in terms of operation in dense foliage, we were down here for an event back in December at the TSOA event, which I'll mention more about in a couple slides, but at Camp Blanding, where the very dense, almost jungle-like foliage with big saw palmetto fronds up to above my head. And we deployed Argus in that type of environment, and it worked extremely well. We're showing the picture there of the type of foliage. You can't even really see the Argus node, where we've circled it in red. Trust me, it's there. And then we've shown some top-down views of the same thing in the other of the deployment areas on the other views. As I mentioned, Argus is also capable of being installed permanently, although it was designed for rapid deployment initially, and that's kind of its sweet spot, or its key unique advantage is it can be deployed somewhere very quickly. It also can be deployed and left there permanently. We've done deployments in the Philippines. This is where these images are from, where we have cameras integrated. We've done permanent mounts to the wall, and that is continuing to operate. It's been operating about 12 months now, and it's continuing to have persistent surveillance over that warehouse in the Philippines. This is a kit that we typically will deploy Argus out of. We've actually got it back there. If anyone wants to see it, includes 9 Argus nodes, a gateway, a laptop, basically everything to do the deployment of this type of sensor node that I've mentioned. We have several optional accessories, of course, if you want permanent, uninterrupted operation. We've got solar panels that we can integrate with. We don't invent the solar panels, they're off the shelf, but we opt out for them as accessories. The camera system we're developing with a partner company is shown right there. It's a very small, you can see it with respect to a laptop computer, how large it is. It's designed to be man-packable, and it incorporates a compass, a thermal and a visible camera, and a GPS, so that you can simply deploy it, and again, without calibration, without configuration, have it automatically slew to the Argus alerts as they arrive. So we've done many deployments and demonstrations over the years. Of keynote is the TSOA events, the technical support and operational analysis events that the Army, Deployable Force Protection, and now ASALT host. These have been great events for us to get our equipment in the hands of warfighters and get their direct feedback to help us improve the system, make it more suitable for their needs. So they've been really great. We've also undergone evaluation at the SOCOM TE event, 811th Security Force Squadron with the Air Force. They've taken our system overseas to evaluate it. The Betsy at Fort Belvoir, we have systems based on Argus technology deployed in the Middle East for border protection. as well as all that list. I don't need to go through it all. I think my time limit is up. So for more information, please come see